Hello friends, I am Udayanchana studying 12th in New Delhi Central School. I am here to explain the 5th chapter, that is surface chemistry. Now, let's move to the chapter. What is surface chemistry? Let's have a look. Consider a beaker with water in it. Here, there are two phases or two states. They are the gas, that is the air, and liquid, that is the water. Here, there is an intermediate layer. We can call them as an interface or simply a surface. In that particular interface or surface, many phenomena takes place. The study of the phenomena that occur at the surface or interface is called surface chemistry. In surface chemistry, mostly we will come across phases. They are pure compounds or solutions. Now, you may think how these phases are represented. Let me show you. Yes, this is how they are represented. That is, by using a simple hyphen or by using a simple slash. This is how they are represented. There is an exception for interface. We all know that gases are completely miscible. That is, they get mixed up very well, so no interface exists. Corrosion, heterogeneous catalysis, electrode process, dissolution and crystallization. You may think, why am I saying all these processes? Yes, these are the examples of the phenomena that occur at the surface. To study surface chemistry perfectly, we need a clean and tidy surface, which is not always possible. But under high vacuum around 10 to the power minus 8 to 10 to the power 9 Pascal, clean and tidy surface is obtained. Solid materials should be kept at vacuum, or else the solid will be covered by molecules of dioxygen and dinitrogen. That's all for introduction. Now let's move into the topic. Friends, inside new shoes or tablet bottles, you have seen a white bag with the description "Do not eat." Do you know what it is? Yes, it is silica gel. And do you know why it is kept inside those things? Yes, silica gel has the property of absorbing water and keeping the surrounding dry.
When silica gel is exposed to water, it makes the surrounding dry because the water molecules get adsorbed on the surface of the silica gel.
The process of accumulation of molecular species on the surface rather than entering into the bulk is called as adsorption. Two main terms are involved in this process. They are the molecules that accumulates at surface is called as adsorbates, and the surface in which the adsorbate accumulates is called as adsorbate. Adsorption is the surface phenomenon. Solids, mainly in its finely divided state, have more surface area, and therefore metals in its finely divided states act as a good adsorbents. Silica gel is an example of adsorption. Let me give you 3 more other examples for adsorption. Firstly, when gases like oxygen, hydrogen, chlorine, carbon monoxide, ammonia or sulfur dioxide is taken in a closed container with charcoal, what will happen to the gas? The pressure of the gas decreases. This is because the gas molecules get adsorbed in the surface of the charcoal. Secondly, in a solution of organic dye, let it be methylene blue, we are taking charcoal. Now what will happen? The methylene dye's color become colorless. This is due to the color solution of the methylene dye gets accumulated at the surface of charcoal. In the same thing, aqueous solution of brown sugar is taken with charcoal. What happens to the solution? This solution also becomes colorless. Here also adsorption takes place. It is clear that solid surfaces can hold the gas or liquid molecules. Now, let's move on to the next topic.
Here's an experiment to demonstrate absorption. When sponge is soaked in water, the water molecules enter inside the bulk of sponge.
Friends, now you may think, what is meant by bulk? Bulk is nothing but the inner portion of a substance. Absorption is a bulk phenomenon because the water molecules enter inside the bulk. But adsorption is a surface phenomenon because the adsorbate settles on the surface itself. Now, let's move to the next topic. I have red colored solution in a bottle. On the other hand, I have a chalk. What will happen when the chalk is dipped in the solution? Let's have a look.
After some time, when we break the chalk, it is observed that the surface retains the red color of the solution due to adsorption, while the solvent of the solution goes deeper into the chalk due to absorption.
Let me conclude the experiment. Yes, when both absorption and adsorption takes place simultaneously, the process is called as sorption. Now let's move to the next topic. The process of removal of adsorbed substance from the surface in which it is adsorbed is called as desorption. In this substance, what is happening is, first, water molecules act as adsorbents. Now, water molecules are accumulated at the surface. Here, adsorption takes place. And when we increase the temperature, what will happen? The water molecules will evaporate. And now, the adsorbate is removed. Here, desorption takes place. Now, let's move to the next topic. I am going to explain this process by taking charcoal as the adsorbent and ammonia gas as the adsorbate. When we closely observe the surface of charcoal, we can find minute pores and pits. So, this is the surface of the charcoal. There are many attractive forces on the surface. Now, when ammonia molecules come and sit on the surface of the charcoal, let's see what happens. Now, ammonia molecule is on the surface of the charcoal. In this process, heat is liberated. We all know that if heat is liberated in a process, that is exothermic. As this process is exothermic, this is called as enthalpy of adsorption. We all have learned about thermodynamic equations of Gibbs free energy. Gibbs free energy, that is, we all know that del G means change in Gibbs free energy, del H means change in enthalpy, and del S means change in entropy. As more heat is liberated, the enthalpy is highly negative. And when we come to the entropy, firstly, when the ammonia gas was in atmosphere, it was in highly disordered condition. But when the molecules of ammonia settled on the surface, it came to an ordered condition. So, the entropy also became negative. Now, what will happen to the Gibbs free energy? Let me tell you. Here, now, the enthalpy is negative and entropy is also negative. So, this negative will become positive. However, the change in enthalpy is more negative. Even if it is negative or positive, because of enthalpy being more negative, Gibbs free energy becomes negative. Hence, this reaction is spontaneous. Now let's move to the next topic. Types of adsorption. There are two types of adsorption. Physisorption. Physisorption is also called as physical absorption. Chemisorption. Now, chemisorption is also called as chemical adsorption. As chemisorption is an activated process, it is also called as activated adsorption. Now, let us see what is physisorption. When gas molecules adsorb at the surface of solid by weak van der Waals force, it is called as physisorption. By the way, chemisorption is the adsorption of gas molecules on the surface of solid by chemical bonds. It may be ionic or covalent. Then, physisorption is not specific. We know that van der Waals force is not specific, so automatically physisorption is not specific. Then, chemisorption is specific. Only when there is a chemical bond between the adsorbates and adsorbents, chemisorption takes place. So, chemisorption is specific. option is reversible. We all know that gases adsorb at the surface of salt when the pressure is very high. Now, if the pressure is decreased, what will happen? The reaction will be reversible. So, first option is reversible. Now, chemist's option is irreversible. The process is very slow. It needs to be activated. So, chemist's option is irreversible. That is, it cannot be reversed. Physics option takes place at high temperature. So, enthalpy is low. That is around 20 to 40 kilojoule per mole. And as van der Waals force is inward, it is automatically low. Then, chemist's option. Chemist's option, we know that it takes place when temperature is very low. Here, as chemical bond is inward, the enthalpy is very high. That is around 80 to 240 kilojoule per mole. Now, let's move on to the next topic. So now, we are going to look about the similarities between physics option and chemist's option. There are two similarities. First depends on nature. Both physics option and chemist's option depends on the nature of the gas. Because most liquefiable gas readily adsorbs and there most reactable gas readily adsorbs. This is why both are depending on nature of the gas. Second similarity is surface area. Both physics option and chemist's option happens readily if the surface area is small. I have my explanation here. Thank you for listening to my words initially. Bye. Stay home, stay safe, take care.